Welcome to our online class. Today we shall be discussing Mohr circle. We'll be taking an example on Mohr circle. Mohr circle is an interesting topic. It really helps us to determine a lot of things, stresses and strain. We're discussing stress and strain topic, like a principal stress or normal stress, the principal stresses, the shear stress, and the likes. So today we'll be taking an example, and here we have a structural member is subjected to a tensile load of 70 Newton per millimeter squared and 30 Newton per millimeter squared compressive stress. The shear stress acting is 25 Newton per millimeter squared. We are to determine the principal stresses and also verify our answers analytically. So what we do here first, we bring out the parameters. Let's say the tensile load, that's sigma x. Sigma x is 17 Newton per millimeter squared. And also we have the compressive stress. Let's say that's sigma y, and that is our what? Negative 30 Newton per millimeter squared. You might be wondering why this is negative. We said compressive stresses, take them to be negative. That is a push. Why a pull is tensile, it's positive. And also we have the shear stress. Let's say that's tau xy. Tau xy is what? 25 Newton per millimeter squared. Now we cannot draw this with our instrument. We are having if it's possible for us to have a very big space, we can draw them, but we are going to use our normal draw instrument, our compass and our ruler. So it's better we select a scale so that we can reduce these dimensions. So let's select a scale. Let's say on our scale 1 centimeter will represent 10 Newton per millimeter squared. So from here, sigma x will be equal to what? 7 centimeter. That is 17 Newton per millimeter squared divided by 10 Newton per millimeter squared. Also, sigma y is going to be what? Negative 3 centimeter. And our tau sy is going to be what? 2.5 centimeter. Very good. Now, straight to Mohr circle. How do we now draw a Mohr circle? In this case, where we have shear stress, it's different from where you don't have a shear stress. Take for instance, you are given sigma s and sigma y with an angle. You would have just taken a point A. Then from point A, you measure sigma s and sigma y. Then take the radius of sigma y, sigma s and sigma y. You get the center, draw the circle, then you get the angle. That is in cases where you don't have shear stress. But because we have a shear stress, the first thing we do here, get a center. Let's say we get a center. Let's say point A. So through point A, we have a center line. Now, what you now do, you come here, you see your sigma s is 7 centimeter. From here, measure 7 centimeter in the rightward direction. So from here to here is what? 7 centimeter. That's sigma x. Now sigma y is negative, so it's going to be what? In the leftward direction. So you measure negative 3 centimeter. So let's call this point A, and let's say this point is what? B, and let's say this point is what? C. So here is what? Sigma y, and sigma y is what? 3 centimeter. Now we look at our shear. Our shear is 2.5. So from B, you measure 2.5 upward, that's perpendicular. you use your set square. You measure 2.5. So from here to here is 2.5. 2.5 centimeter. That's our share. Then you come to this side of C. You do what? You measure 2.5. 2.5 centimeter. From here to here, it's 2.5. So let's call this point D and this point E. Take note. Again, I repeat. What you do, get a center, a point, any point, convenient point. Get a vertical line. Then from that point, measure sigma x, which is rightward to the right. That's 7 centimeter. And sigma y, which is negative to the left. That's negative 3 centimeter. Then from your point B, measure 2.5 upward and 2.5 downward. Now what you now do, you join D to E. D to E. You join D to E. Now, where they meet, call that point O. You can see, now, when you join D to E, place your compass on O, taking OD as radius or OE as radius. Then, draw a circle. That is the Mohr circle. That will cut through E and back to D. Now, it is now certain that I have to extend my line. So it's better when you start your own diagram, you extend the line. Draw the line conveniently. You know, convenient lines. Now, from here, I will label these points M and this point N. Now, the question says we should determine the principal stresses. I will be able to determine my principal stress from this Mohr circle. Now, my sigma maximum will be my distance from A to M. That is AM times scale. If I take my ruler and I measure my AM, I'm going to have 7.6. 7.6 times scale. My scale is 10 Newton per millimeter squared. Times 10 Newton, per millimeter squared. So, automatically, my sigma maximum, that's my maximum principal stress, is what? 76 Newton per millimeter squared. Take note, from point A to point M. That's my maximum. So automatically it means from A to N will be my what? Minimum. By measurement. So my minimum principal stress is going to be what? Minimum principal stress is going to be AN times scale. That's AN times scale. So if I measure AN, I'm going to have negative 3.6 times 10 Newton per millimeter squared. So that's going to give me what? 36 Newton per millimeter squared. So I've been able to derive my principal stresses using the Mohr circle. Don't forget, get the center, measure rightwards, sigma x, positive to the left, negative. Then the shear stress, measure upward and downward. This is negative, so we have a negative shear stress, positive shear stress. Shear stresses oppose one another, you know. Then, taking the radius, by joining your point D to E, where they meet, call it O on the horizontal. Where it meets the horizontal, call it point O. Then you draw the circle. From there, from your A to your M is principal stress. From your A to your N is minimum principal stress. Make sure you always remember to multiply by scale. Now, by verifying analytically, you already known that your maximum principal stress is sigma x plus sigma y divided by 2 plus the square root of sigma x minus sigma y over 2 all squared plus tau squared. So if I put my value, my sigma s is 70, my sigma y is negative 30, my tau xy, that's what we have here, tau xy is 25 Newton per millimeter squared. So by inserting these values, we have 70 plus negative 30 divided by 2 plus square root of 70 minus negative 30 divided by 2 all squared plus my share is 25 all squared. If I solve this, I'm going to have my sigma maximum to be equal to 76 Newton per millimeter squared, which checks this. It checks the graphical method. Likewise, my sigma minimum, the formula is the same, only that this positive sign will change to negative. So I'm going to have sigma x plus sigma y over 2 minus the square root of sigma x minus sigma y over 2 all squared plus tau all squared. Now I'm going to have 70 plus negative 30 over 2 minus 70 minus negative 30 over 2 all squared plus 25 all squared. By solving this, I'm going to arrive at my minimum principal stress to be equal to negative 36 Newton per meter squared, which is what I have here. So this is negative 36 Newton, negative 3.6 times 10, negative 36 Newton per meter squared. So this also checks this. So we have seen how interesting Mohr circle is. So thank you for watching. Please do so well to like the video and comment. We meet in the next class. Thank you very much.